Welcome everyone to today's webinar, Blockchain Use Cases with Big Impact. I'm Morgan Hafner with Becker's Hospital Review. We will begin today's webinar with a presentation and we'll have time at the end of the hour for a question and answer session. You can submit any questions you have throughout the webinar by typing them into your control panel in the space labeled Enter a Question for Staff and clicking Send. We are looking forward to hearing your questions. Today's session is being recorded and will be available after the event. In about a week following the webinar, we will be sending all registrants a copy of the presentation to the email you used to register. At this time, it is now my pleasure to start today's webinar by introducing our presenter. Emily Bailey oversees Change Healthcare blockchain development and integration strategy. Prior to joining Change Healthcare, Emily assisted startups, small businesses, and enterprise companies, cryptocurrency, and blockchain adoption. She has worked across many markets, retail and e-commerce, healthcare, insurance, and finance. She's a founding contributor to Distributed.com, Distributed Health, and the Hyperledger Healthcare Working Group. At this time, I am pleased to turn the floor over to Emily to begin today's presentation.
Thank you, Morgan, and thank you everyone for joining us today for this webinar. I'm really excited to be talking with you and to introduce some cool work that Change Healthcare is doing in blockchain, and also to introduce some ideas that we have around where we see the technology going for the industry. So just to give a little more context into my background, I joined the blockchain movement back in 2013 with Bitcoin technology before blockchain was really even being talked about as an enterprise solution. And so I've been working with this technology for around 6 years and have watched it transform from being mostly, alternative currency solutions to seeing it evolve across multiple industries, multiple use cases where you have tokens being used for different types of applications, and then you have applications and blockchain solutions that don't use tokens at all. So there's a lot of you on the line today, and you may be approaching this technology from different areas of interest. And so for today's webinar, we're primarily going to focus on enterprise use cases for blockchain technology, and many of those don't currently focus on the use of cryptocurrency or tokenized solutions underneath. But happy to answer questions towards the end if you do have some questions around the role of that. So I'd like to introduce Change Healthcare. Change Healthcare is a large independent healthcare technology company based in the United States, based here in Nashville, Tennessee, where I'm broadcasting from today. We're primarily known for our comprehensive intelligent healthcare network, which is essentially a clearinghouse network that connects thousands of payers and providers and is responsible for processing nearly $1 trillion in healthcare claims a year. So our network infrastructure is considerable in terms of size and scale, and this is a really important thing to consider when wondering, why Change Healthcare is developing blockchain solutions and why we're approaching the technology the way that we are. I like to introduce Change Healthcare in the context of our network because blockchain technology is a network technology. And so it is an infrastructure that exists in the network layer of information systems. And Change Healthcare has one of the largest healthcare transaction networks in the world. And so when we think about where blockchain technology is going to impact our solutions, we have to think first about that infrastructure layer and then the applications and services that exist on top of it. So before diving into what Change Healthcare is doing with blockchain technology, I want to introduce the problem that we think blockchain technology can really address in healthcare. We know that the healthcare industry has seen opportunities to reduce waste. We estimate that there's around $1 trillion wasted in the healthcare industry every year. And those can be attributed to clinical waste, administrative complexity, excessive or opaque pricing models, and fraud, waste, and abuse. And much of that waste can be attributed to redundancies, errors, inefficiencies in how we handle data and how we handle the exchange of information between the multitude of caregivers and service providers and payers and participants in the healthcare system. The way that we see it is this healthcare transactions rely heavily on costly data reconciliation. In today's world, you may have multiple entities or multiple parties involved with the delivery and financing of patient care. And each of those parties is going to have to compile information across the healthcare continuum in order to power their own business decisions. So we define data reconciliation as this process of compiling information across multiple companies in order to complete your set of records so you can make a business decision. And this is just a necessary function of how we make decisions today. And data reconciliation is just a part of building out your knowledge base. But unfortunately, it's redundant. We end up reconciling a lot of duplicate information sets. You have multiple parties that are performing the same functions as everyone else. And it's error prone. So we're processing a lot of error prone data and adding that to our system, meaning that even the data we're ingesting and adding to our records, we don't really trust. It's expensive in terms of time and resources and money that it takes to get this information and build our records out. And most importantly, it's ineffective in delivering a trusted and consistent information set. So again, based on the data that we are compiling, we don't really trust the information that we have, and so we're only able to really make decisions based on our best guess in some cases. So we see blockchain technology as being able to offer a solution to data reconciliation in the form of data integrity. Data integrity is the concept that we can prove that data hasn't been manipulated, or that the data that we're looking at is the information that we requested, or the information that we originally created. And the data integrity is a small component of an intelligent solution that's needed to power business decisions, but it's really important because being able to know and to prove that the data you're working with hasn't been manipulated can really improve your ability to trust that data. So blockchains are just a sliver of the total solution. And what they do is provide a shared system of identity, so your ability to identify data and the users that contributed it. And it gives you a shared system of chronology. What happened when? When was this data added to the system, and what actions have been taken against it? And it gives you a system for proving the integrity of the information that you're looking at on the blockchain by using cryptography, standard cryptography. You can use the blockchain to prove that the records that you're evaluating haven't been manipulated. What's really important about the blockchain solution is that it relies on a mathematic set of principles to establish this shared record of truth. And using mathematic principles, that means that any participant or any company who's engaging with the blockchain can independently verify what they're looking at. They don't have to rely on business relationships or trust dynamics, social trust dynamics in order to trust the information that they're seeing. They can use math-based functions to prove that the information has integrity. And that's important from a programming, a technical standpoint of being able to ensure secure automation and other types of technical functionality. The benefits that we see from blockchain adoption initially include security, the ability to track interactions across multiple companies with full integrity, knowing that a certain party did a certain action at a certain point in time and being able to independently verify that. Transparency. We think that by using a shared record of truth, it will make it easier for companies to collaborate and share information around a shared workflow. For example, the processing of a claim or the construction of a patient's medical record. And the blockchain's distributed ledger provides a historical record of activity. So not only are we able to coordinate in real time about what's happening right now, we all have the same information about what's taken place in the past, which can be important for auditing purposes. And additionally, we see that the benefits for blockchain adoption in the short term could be efficiencies gained, reducing the need to reprocess or reconcile information that's already been collected. It's important to know that blockchain technology is really designed to be more like a transactional log or an event log of transactions that have occurred. A lot of times you hear use cases such as putting medical records on the blockchain or processing claims on the blockchain. And these are all viable use cases worth exploring, but it's important to consider the blockchain as a card catalog or an index of available information. If you're familiar with the library catalogs of the olden days, I guess. The card catalog was a wooden box in the library that contained index cards that would tell you where to go in the library to look up a book. A blockchain is a very similar type of function within an information system. It contains indexes to where data is stored or references to events that have taken place, but it's not the actual library itself. It's not the file storage system itself. So one of the biggest misconceptions I hear about blockchain technology is that you actually put data into the blockchain ledger itself. And there's a couple of reasons why you'd want to avoid doing that. One would be privacy and security. If the blockchain ledger contains all of the data, then it really limits the types of information you can put into it, because everyone has an equal and transparent view of the blockchain. So you don't want to put private information into the blockchain. The other reason why you would avoid storing data in the blockchain is it impacts the performance of the blockchain network. The way that blockchains are constructed, they synchronize. The blockchain ledger synchronizes itself across a network of servers and computers that have copies of the blockchain ledger. So if you add a really large file to a transaction, then it slows down the ability of the other computers that are running the blockchain network to synchronize with that transaction set. So the idea is to keep your blockchain transaction about the size of a text message, and use that transaction to reference data that is stored at the edge in an external database or cloud system. So I'm going to give you guys an example of how we think about blockchains that change healthcare today. In today's world, when it comes to claims, you may have multiple parties, and so for the sake of our example, we're going to have 4 basic parties. You have the patient, the payer, and the provider, and an IT company, the data processor, who helps translate information back and forth between the payer, the provider, and the patient. And when the provider creates a claim, they usually send it to a central clearinghouse or a data processor who translates that information and shares it back with the payer, the provider. And this kicks off a series of communication events with the patient, with the provider, as each party seeks to reconcile their information set and complete their version of truth when it comes to the status of the claim and what actions need to be taken next. So I use this slide to communicate that we don't have in today's world a shared infrastructure for understanding what the status of the claim is. Each party has their own version of events, their own record of truth that they're reconciling against everyone else's. Blockchain technology was invented to address a problem called double spend, which is when you write two checks from one bank account and the bank doesn't know which check to cash first. And this double spend scenario, it creates a challenge for reconciling which check you want to cash. And in healthcare, we have all kinds of double spend scenarios that could be addressed by having a single record of truth. In this example, you may have a patient who asks their payer and their provider, or who asks all the counterparties at the same time, what do I owe on this claim? And the payer and the provider may have different answers to that question. And this is just a byproduct of the fact that our information is asynchronous, and we can reduce this by having a shared version of events. The impact of not having that creates a broken trust relationship between the payer, the provider, and the patient. On one side, the payers estimate tens of billions of dollars to fraud, waste, and abuse every year, where patients and providers are abusing the inefficiencies of the claims processing system in order to guarantee the reimbursement or the rate that they want. And on the provider side, they estimate that nearly $20 billion annually are lost due to errors in the claims processing, because it's so difficult to consistently and accurately process claims against all of the payers that they do business with. And as we know, when information is incongruous and it's being communicated to the patient, that decreases the likelihood that the patient's going to pay their bill on time, which puts further strain on the relationship between the payer and the provider as the patient's responsibility increases. So looking at a blockchain-based system, what we want to show here is that we can create a shared record of events around what constitutes the claims process and what actions have been taken. So in this basic example, a payer would create rules for how its claims need to be processed, and they would publish these rules to the blockchain like a smart contract. This basically means if you want to create a claim for a regular physical checkup, this is how the claim needs to be structured in order to be processed, and they can publish this rule set transparently to the blockchain. That way, when a provider creates their claim, they're invoking that rule set, which automatically notifies all the other parties that that this is the rule set that's going to be followed for this claim, and it communicates what they can expect next. Now, as the data processors provide additional insight on what the claim contains and what the services were charged, and potentially what additional data might pertain to the insurance provider around the risks associated with adjudication, they can add that in a transparent fashion to the claims process. When the patient makes a payment, this event can be recorded subsequently as well. And when the rules for the claim are complete, all of the counterparties can be notified in real time and have a real-time view of the activities that have been taken against this claim. And when the claim contract is fully complete, it's recorded immutably, so it's recorded permanently onto the blockchain, and it creates a record that each party can reference later on. Before I move on here, I think that what's important to take away from this is a couple of things. One is that we're not replacing the fact that each counterparty is going to have their own private ecosystem, their own understanding of data and activities that are taking place. What we're adding here is an additional environment that allows the counterparties to collaborate more efficiently with each other. So you're only sharing the data with the blockchain that you want to share with the other parties. It's a transparency measure that you can take. It's not a matter of sharing all of your data with all of your competitors, for example, but it's a mechanism for sharing the updates that need to be shared in order to facilitate collaboration. Another point that's important to consider here that's not exactly illustrated in these slides is that we're not adding a fifth company here. We're not adding a fifth counterparty. What's actually taking place, ideally, is that each individual participant has their own copy of the blockchain that's stored locally in their environment. So as they add transactions to their blockchain ledger, it's reconciling against everyone else's in real time through a process called consensus. And this is an important thing to think about, because this is what makes blockchain technology so secure. When there are multiple copies of the ledger stored locally or in the private clouds of all the different counterparties, it becomes resistant to attack. So if one of the counterparties wants to lie or change a transaction from what was originally recorded, they would have difficulty doing this without having to basically get every other counterparty to update their system to reflect the new changes at the same time. So blockchains are considered to be attack resistant, and this is a feature that we should consider when we're thinking about where this technology lives within our system. So, Change Healthcare has actually been applying blockchain technology to a variety of use cases across clinical data, patient engagement, and financial use cases in revenue cycle management and payments. And since we began working with the technology 2 years ago, we really see an opportunity to focus on revenue cycle management and payment use cases. So that's kind of where we're going to take the conversation from here. So the big picture that we see is that blockchain networks can enable real-time adjudication. Real-time adjudication is basically the nearly instant determination of a payer's contribution to the claim based on their predefined logic. So we know what certain claim events should be paid according to the policy information and the risk profile. And it takes a lot of time to actually reconcile that information and adjudicate a claim. So we think that by exploring the role of smart contracts and the predefined logic that can be stored on the blockchain, we may discover efficiencies around the adjudication process. In order to achieve real-time adjudication or straight-through claims processing on the blockchain, we need to have an infrastructure that can support this. This is not an application. This is not necessarily a software capability. The way claims are adjudicated today has a lot to do with the network infrastructure that underpins our software. So in order to address real-time adjudication, Change Healthcare has been partnering with other IT companies to explore the role of blockchain in sort of the guts of the claims process. So we've partnered with Amazon as a cloud provider on our intelligent healthcare network, and we're redesigning our clearinghouse network for the cloud. And with that, we're exploring AWS's blockchain capabilities. Additionally, we've been working with TIBCO, which is an IT provider that focuses on business intelligence and integrations. And TIBCO has a number of open source capabilities designed for blockchain application development. One of their projects, Project Dovetail, specifically targets smart contract development. And Change Healthcare announced last year that we would be working with TIBCO to explore how to build a smart contract platform that's open source and modular for the healthcare ecosystem. You know, the desired or the ideal end users of this are going to be app developers in the healthcare industry, but it's an effort to bring the technology up to a level where more people can access it. Additionally, we acquired a company called PocketDoc at the end of the year, last year, at the end of 2018. PocketDoc was a leader in blockchain technology, both in terms of blockchain network development with the DocChain platform, and some interoperability and API development that they had contributed to the blockchain industry. And so we're in the process of making those capabilities extensible through our blockchain infrastructure. One of the other solutions that we've developed is around claims lifecycle transparency. And this is one that we actually have in production today. So Change Healthcare has been in production with blockchain technology for over a year. We have a blockchain network that runs in parallel to one of our clearinghouse networks, and it captures claims lifecycle events from the provider software that's connected to it, so that the providers can see the status of a claim or the history of the claim via API. And one of the reasons we chose claims lifecycle transparency as a core solution for blockchain is that it can help us reduce fraud, waste, and abuse by creating transparency between all of the applications and parties that are connected to the blockchain network. And we think that having a 360 view of the claims lifecycle will be really valuable in decreasing resources spent on processing payments and other financial services against the claims process. And the component of this that I'm personally the most excited about is the idea that having this blockchain infrastructure that captures claims events, it increases the visibility not just to payers and providers, but also to patients in the long run. We think that that blockchain technology is highly extensible and easy to incorporate into mobile and other highly mobile applications, and that it will create an environment that's easier for us to engage patients around this information. So if you can imagine, the patient having a view into claims lifecycle activities that are pertinent to them, this is something that that we have in mind for the future. So this solution runs today as a Hyperledger Fabric network that runs in parallel to our existing clearinghouse. The way it works is a provider submits their claims activity through the software application that they use, and the software communicates with our clearinghouse, which which basically broadcasts certain types of events to the blockchain network. And we have developed a couple of APIs that allow the provider to look directly into the blockchain network and see this claims activity. Now they're able to see this claims activity through their software itself. The API access is just an additional functionality that we've added. The real thing that we were trying to achieve with this blockchain network is to demonstrate the scalability and the performance capabilities of the blockchain itself. At the time that we began exploring this, blockchains were considered not scalable, very slow, extremely clunky networks for enterprise systems. So we needed to prove that blockchain networks could actually perform well in a high throughput healthcare environment. So we had to test Hyperledger Fabric's ability to process a production volume of blockchain transactions and claims volume. And we were able to achieve a production requirements with 550 transactions per second and around 50 million transactions a day. That's what the blockchain network can sustain, but production requirements are somewhat lower than that. So we have room to scale and add more transaction capabilities to this network, which is what we needed to bring the infrastructure into production. And so finally, this is a new proof of concept that we've been developing. But this year we have been exploring payment reconciliation on the blockchain. So in today's environment, one of the challenges that we have in data reconciliation has to deal with how payments are distributed across an ecosystem of participants. So in today's environment, Change Healthcare would receive a payment request through a claim file. So we receive a file that includes payment instructions after the claim has been adjudicated. It says to pay a certain distribution from this payer's bank account to this provider's bank account. And in some cases, we may be talking about multiple providers or multiple recipients of a payment distribution. So these payment distribution instructions can get pretty complicated. And there's a great deal of manual reconciliation that goes into matching the payment instructions with the distribution system. So we have to take the payment instructions in, we have to match them with existing contracts that we have on file to make sure there's no discrepancies between the instructions and what is contractually required. And then we have to set up connections between all of the banks, the payment processors, and the recipient organizations, which can include anywhere from 7 to 8 individual companies that need to be notified in a single workflow of just distributing a payment from a payer to a provider. At a minimum, there's 4 banks, 2 data processors, and 2 companies, the payer and the provider, that need to be notified of a payment being sent. So this is a pretty complicated network to set up. And what we've been looking at with blockchain is the ability to use smart contracts as a mechanism for storing the distribution logic ahead of time, so that when we receive the payment instructions, it's like an event notification that triggers a series of automated activities that notify the required parties and request inputs from them on what needs to happen next. Sometimes they need to sign off, sometimes additional information is needed, and we can capture the required steps in the smart contract template that gets filled out as event notifications hit the blockchain network. And this is a really interesting way of creating collaboration between multiple companies, not only because we're talking about using smart contracts to create secure automation, but also we're creating a peer-to-peer network where payers and providers can communicate directly with each other. They can communicate directly with their banks. So on this network, we're not just talking about connecting payers and providers directly, but also including financial institutions to speed up the payment lifecycle. Our estimation is that if brought into production, if fully operationalized, we could decrease the payment delivery window down from 7 days to 30 minutes or less. And this is a really exciting capability, because we're talking about a scenario in which the payment has already been agreed to, and it's just a matter of getting it in the hands of providers. So if we can get our providers paid faster, we think it'll improve the relationships between everybody involved in the payment life cycle. We've been working with a company called Digital Asset Holdings, as Digital Asset, I think is what they're commonly known as, and they're a blockchain platform for the financial industry that has a smart contract system called DAML that they use to create smart contract workflows. And it's been a really cool experience working with them, and from here we're going to continue expanding on our payments POC to handle exceptions, in-flight changes, errors, and more complex payment reconciliation challenges to see what the features and limitations of the smart contract systems are. So, in thinking about what is next for blockchain and technology in healthcare, I kind of want to leave you with three main points here. So, blockchain technology is inherently an infrastructure technology. It's got a lot of hype right now. This is something that almost every company in healthcare is wondering about, talking about. It takes the main stage at all the major conferences, but it is an infrastructure technology, and it's much like the early internet in the sense that it's a networking technology that enables really cool applications. So the internet gave us email. That was a killer app for internet adoption in a business context. Blockchain technology is still finding its killer app in the healthcare industry. And so a lot of the companies that are developing this technology today are focused on building out the capabilities of the infrastructure so that it can support applications that make it relevant to healthcare's end users. So a lot of the exciting innovation that's happening is going to end up being buried behind software, and in the future we may be using blockchain networks without even really knowing it, and that would be a good thing, right? So it's important to consider when we think about where we are in the adoption curve. We're still very, very early. Another thing to think about is what is blockchain's impact going to be to your business? When you're thinking about where does my company fit in the disruption landscape, where does my company fit in the innovation opportunities that blockchain brings about, the way that I like to compare it is think about how your company uses network technology today. Are you a network developer, or do you connect to a network through the software that you use? What is your role with technology today? Are you guys, do you have a big innovation team where you build your own apps and services, or do you work with IT companies to customize software and services to your environment? Your relationship with blockchain technology in the long run is going to be very similar to that. There are a lot of early adopters that are getting involved in application and use case design, but how they actually end up interacting with the technology is going to reflect how they use network internet technology today. And finally, blockchain networks are really about building an ecosystem of applications. A blockchain is not really a product so much as it is an enabling technology that can support a wide variety of applications and use cases. And so the idea that, you know, a claims lifecycle transparency solution like Change Healthcare's exists on one blockchain network, that should be able to coexist with a payments application and a patient medical record application. The underlying infrastructure should be able to support a wide variety of competitive and complementary services. And so that's the goal when we think about building these blockchain networks, is you don't want to have one blockchain network for every use case. You'd rather have a bunch of use cases on one network. So, so I'll leave you with that, and I'm happy to answer any questions that, that may be lingering.
Thank you, Emily, for that fantastic presentation. We will now begin today's question and answer session. Please submit any questions you have by typing them into your control panel in the space labeled "Enter a question for staff" and clicking "Send." We will try to get through as many questions as we have time for. There are a ton of excellent audience questions coming in. And Emily, the first audience member is wondering, the data integrity definition sounds similar to data handshakes. How does blockchain data integrity differ from data handshakes?
So I'm not familiar with the term data handshake. I am not sure. I'm not sure if my answer here is going to help. But one thing that I like to kind of I guess talk about here is that data integrity is fundamentally different than data accuracy or data quality. A data integrity measure really just proves that the data that's been created or the data that's been submitted hasn't been manipulated since it was originally created. And so so the need for analytics tools and quality measuring tools to assert that the data is actually valid or that it's accurate, those are still going to be needed and aren't typically functions that would be performed by the blockchain. The blockchain will just tell you that since this item was submitted, it hasn't changed its state.
Excellent. Thank you for that answer, Emily. Another audience member is wondering, are we referring to a public blockchain, or is this a claims accounting system proposal, a private solution between some carriers and providers and patients?
Yeah, so assuming that we're talking about the example infrastructure I kind of laid out, where you had the 4 parties submitting events to a blockchain network, we're likely talking about a permissioned or hybrid system rather than a fully public, fully decentralized system. I do believe that all blockchain networks will eventually capitulate towards open, decentralized, permissionless networks, but there is going to be a path, a transitional path to get from private networks to public networks, similar to how the internet was originally adopted. There really isn't a lot of value in running a private network, so the intention here is not that the data processor or that the IT company is running the whole network by itself. The intention is that the network is distributed amongst the participants that are participating in the workflow and other participants that aren't represented in the diagram. How the permissioned or hybrid blockchain ledgers get adopted is not just a question of technical feasibility, like how does the consensus mechanism work? It's also a question of the financial viability of the network. What does it cost to run a node? And what is the value to my company for being a node operator? Are there transaction fees that I can participate in a revenue share around? Is there subscription fees that I can get a revenue share from? Or are we just running this infrastructure for free for the good of everyone involved? I think there's some questions that still need to be addressed by the healthcare industry about how we want to monetize and operate distributed ledgers amongst a wide variety, a wide ecosystem of participants. But the vision, at least that we have at Change Healthcare, is that these networks do need to be distributed. They need to run as a distributed or decentralized utility that that large and small companies have access to. But I do want to kind of focus on that for just a second. You know, if you think about the public networks that exist today, Ethereum, Bitcoin, these big public blockchain networks, you can participate in a blockchain transaction without having to store a full copy of the blockchain network on your computer. You can participate in the blockchain ecosystem without having to operate a node or without having to mine transactions. And so as healthcare seeks to adopt blockchain infrastructure in our information systems and applications, you know, we have to consider those models as well, that a patient may access the blockchain network through API. Providers and payers, large systems, may actually be running node infrastructure, so they have a local copy of the blockchain network on their systems, but they may just be relaying transactions rather than participating in the consensus mechanism. So there's a lot of discovery left to be done in terms of how these networks actually get distributed and decentralized, and who participates in the consensus mechanism, and then, you know, what the cost and value is for everyone involved. But I would hesitate to put a lot of stock into a fully private solution. The private solutions that get developed, you know, should all be targeting a degree of permissioned or shared capabilities in order to really capture the purpose of the blockchain.
That's an excellent breakdown with so many great examples and questions. Thank you so much, Emily. Another audience member is wondering, would these processes only record at the time of adjudication?
I'm not sure I understand what was meant by the question. Can you repeat the question again? What the processes?
Would it or the processes blockchain only record at the time of adjudication?
I think it depends perhaps on how the claims process is set up. You can take an adjudication workflow and break that down into multiple steps. And as those steps are completed, transactions are created and posted onto the blockchain ledger. You may design it in such a way that the only transactions or events that are being communicated are happening once the claim has been adjudicated. It sort of depends on the design of the solution. Now, if your question is in reference to how our payment POC works, the payment POC specifically addresses payment distribution events that happen once the claim has been adjudicated. So that proof of concept is not really addressing how the claim is processed. It's really just addressing what happens after the claim has been approved by the payer for payment. And so it receives the adjudicated claim file with the payment instructions from the clearinghouse, and it kicks off its own series of activities, and it's not really getting into the adjudication workflow at this time. We could go upstream with the smart contract capabilities that Digital Asset has, and this is certainly something that we're exploring, but there's just so much efficiencies to be gained in how we handle and distribute payment data right now that, that there's still a lot to uncover in that aspect of the workflow on its own.
That makes sense. And the next question actually has to do with smart contracts. Is TIBCO, am I pronouncing that right? TIBCO is developing rules. Is TIBCO developing rules engine on the blockchain for those smart contracts?
Yeah, so TIBCO, and I certainly encourage you guys to go look this up. TIBCO has all the details about what Project Dovetail is posted publicly on their TIBCO Labs website. So Project Dovetail is an open source smart contract orchestration system. And it's designed to be modular in the sense that you can run this smart contract system, this smart contract platform in any cloud, and you can connect it to any blockchain network. Currently, I believe it's compatible with Hyperledger Fabric, and I may be getting this wrong. I think Ethereum. And because it's open source, you can build modules that allow it to connect to any blockchain network of your choice if you're an open source developer and want to get into that. But the idea is that what Project Dovetail provides is a visual organization tool. So you can go into Dovetail and you can set up essentially jobs and activities. So you can create tasks and workflows. Like if I wanted to create a proof of existence for a medical record, I can create a series of jobs and activities such as send a transaction to the blockchain, send a request to an off-chain data store, create a permissioning schema for a payer, a provider, and a patient. And you can represent each of those steps as an individual job or activity, and then you can drag and drop them to create a workflow, and then you can use that to generate a smart contract. And the smart contract that's generated will be written in the native chain code for the blockchain network that you want to write the smart contract to, and then you can design all of this in whatever language you use, whether it's Go or Java. You can kind of create the workflow that you want and then translate it to the blockchain chain code that needs to be generated to write a smart contract. So it comes with some out-of-the-box capabilities, like it supports some Lambda functions for some of the AWS things you may want to do. But it also has the ability for you to build your own capabilities into it because it is an open source project. So if you're an open source developer and are really interested in sort of the capabilities of edge computing and running blockchain processes in a modular environment, I would highly recommend checking out Project Dovetail.
Great, thank you for that breakdown. We have so many good questions coming on. Thank you so much to the audience for sending them our way. And the next question is, they were wondering if your application is a private blockchain with no cost of adding a block.
So the Change Healthcare blockchain network that we have running in production today is a Hyperledger Fabric solution, and it currently is designed to be a permission blockchain, but we do, as a company, we do operate all of the nodes ourselves. And so there is no cost, say for any of our customers who wanted to activate a private channel or they wanted API access. It's not a service that we're monetizing today, and that's just the choice that we decided to make with it, because it provides this additional reference capability, but they have the ability to view their lifecycle events already in their software. The future that we imagine for this network is actually we're transitioning it to be a cloud-based solution. So it's something that we want our IT partners, other clearinghouses, and technology companies that connect to our network today to be able to join this blockchain network as a peer, which would mean that they can operate a full node and participate in the consensus process. And right now we don't have a cost model built out around that in terms of what would it cost to join, or what would it cost to run the node. We do, I mean, the blockchain transactions, they do build onto the ledger. So joining our network and running a node would mean whatever the cost is of running that node infrastructure in your cloud environment. So it would depend on your Amazon credits or whatever you have set up with your cloud provider. But there's no additional cost that Change Healthcare is putting into the service right now.
That's really interesting. Thank you for clarifying that. The next audience member is wondering, in slides 16 through 17, you mentioned each of the parties are protected from data being changed, making it difficult for data to be attacked. Providers are able to make late entries and clarify documentation, also referred to as addendums. If claims are submitted in real time, how would blockchain have to be set up to accept the new data that could decrease or increase contractual payments?
Yeah. So that is a real world challenge that we're thinking about when it comes to actually setting blockchains up to do real-time adjudication. So to clarify for the audience that may still be listening here, we have a blockchain is an append-only data structure, which means that once a transaction has been created, it can't be removed, it can't be edited. So if you create an event and then later on you have a new event that should replace that event, or it changes the nature or it changes the outcome that you're trying to push through the claim process. The way that we have looked at this is, one, you can use a very basic smart contract structure to append a certain transaction. And so if my application is looking at the status of a claim and the claim status has been updated, you basically use the blockchain and the smart contract system to route my application to the most recent version of the events that have taken place. But if we're using it to set up a series of automated activities, such as automation, like payment automation, and the distribution or the adjudication amount, or the amount, the payer contribution amount is going to change. We consider this to be like an in-flight change, and so we're not really sure today exactly how to set up the blockchain to handle in-flight changes, and how to set up smart contracts to handle exceptions. This is something that really needs to be worked out in order to really address, I would say, real-time adjudication or straight through claims processing on the blockchain. I think it's a great deal of complexity that we need to consider, right? For example, if you think about how Bitcoin transactions work, when you send Bitcoin from one person to another and you make a mistake, you can't unsend that Bitcoin. So in healthcare, we have a lot of back and forth when it comes to how transactions are processed and how agreements are made. And so we think that there is, we think that a lot of those agreements and sort of event handling procedures can be managed through a combination of smart contracts and sort of middleware, like off-chain logic. And so that everything that's actually recorded to the blockchain is as near to the final state as it possibly can be. But it's a design challenge that needs to be considered for real world applications. Another way to think about how the blockchain may actually be applied is that our traditional way of processing claims, where there is a lot of back and forth and there are a lot of in-flight changes that take place through the claims process, that perhaps applying blockchain technology to claims processing doesn't mean just wrapping a blockchain around the way we do things today. It may actually mean innovating on how claims are processed today maximize or optimize for the features of blockchain technology. One such model would be looking at claims that are low risk, they're very predictable, they always follow the same pattern of approval and distribution and payment distribution or financial contribution from the payer, and kind of carving out that subset of claims activity and designing smart contracts for that while using the more complex claims process for using the blockchain differently for claims processes that have a lot of discrepancies usually involved. And so at Change, we've talked about using AI to identify claims that are low risk, predictable, maybe they're dealing with preventive care, and pushing those through a blockchain-based automation process while reserving the more complicated claims for a different infrastructure. But these are really experimentations that we're doing with the adjudication process on the blockchain.
Yeah, thank you for that really great question and informative answer. We have another audience member that's wondering about when you mentioned blockchain as not storing actual data, but only the events to ensure integrity. Where is that data stored? Is the data stored centrally or distributed?
So, there's a couple of answers in that. So one, the way that data integrity is captured on the blockchain is, say we're talking about a medical record and we want to create a proof of existence, or we want to post or register that medical record onto the blockchain. What we do is you take what's called a cryptographic hash function. So you run an algorithm over the medical record, and it produces a unique data signature that's based on the content of that medical record. So all of the individual fields, all of the data that constitutes that medical record, including a timestamp of when it's being reported to the blockchain and the application that's submitting it. So it produces a fingerprint for that medical record that's as unique as possible. And that fingerprint looks like a long string, a series of alphanumeric characters, AZ1 to XY, etc. And you just publish that fingerprint onto the blockchain. And then the medical record itself is going to be stored in the EHR system, or it's going to be stored in a database that's specific to the blockchain system but is not on the blockchain. So if we're talking about a system that's owned by the provider, this would be the provider's database. If the document was created by the patient, it might be that the record, the data is stored on their phone or in their G drive or something like that. But the medical record itself is not stored on the blockchain, just that fingerprint. And so what happens is, if you go into the local data store, if you go into the off-chain, off-blockchain data storage, and you make a change to that medical record, say you change the birthday or the social security number, when you run that cryptographic hash function over it again to produce the data fingerprint, it's going to produce a completely different data signature than the original one that was created. And so when you go to share that information over the blockchain, or you want to go check it later, you can prove that the record has changed its state and in the database that it was stored in. And so if in a practical example, if a patient is storing the record and they're making changes to their medical record, and the doctor is requesting that they send the record to them, for example, the doctor would be able to use the fingerprints that are stored on the blockchain to monitor and to prove that the data that they're receiving has changed from the data that they originally requested and the data that was originally recorded. So the integrity component is the cryptography, is the cryptographic function that's reported onto the blockchain, and the actual record itself is going to be stored off-chain with the owner of that data. And so that does require that the off-chain data storage is compatible with a blockchain system, that the blockchain that the off-chain data storage has some ability to communicate with the blockchain and run integrity checks against it. And this is an area that's experiencing a lot of development in both the startup ecosystem and among enterprise blockchain developers.
Excellent. Thank you so much for clarifying that, Emily. We've just had so many good questions come in today. Unfortunately, that is all the time that we have for our webinar today. And so I want to thank you, Emily, for your excellent presentation, and Change Healthcare for sponsoring today's webinar. I want everyone to enjoy the rest of their day, and we look forward to having you join us for future webinars.